Projectile motion. Here's a ball. I fire it into the air, boom, and it travels in a parabola, hence the name parabolic motion, right? So it's basically any object that's fired into the air, and when it moves, there's a lot of different forces acting on it. It's got a vertical velocity. It's got a horizontal velocity. It's got, of course, gravity pulling it down. So when we solve problems with parabolic motion, we need to do some things. We need to figure out what that horizontal and vertical velocities are before we can move on and solve a problem. So let's look at an example. Let's say I've got an object, maybe I'm firing it out of a cannon, and I'm firing it at 50 meters per second at 37 degrees above the horizon. Okay? Well, what I want to figure out is what's my horizontal velocity, which goes along the x-axis, and what's my vertical velocity, which goes along the y-axis. Okay? If I know that it's 50 meters per second at that angle, and that angle is 37 degrees, I can use some trig to solve that, okay? So if I want to solve for x, okay, I know that x over this value is basically the cosine of 37. So if I multiply this value by the cosine of 37, okay, I have 50 meters per second times 0.08, that's going to give me 40 meters per second. That is my velocity in the horizontal. Okay, that's how fast it's moving along the x-axis. Okay, now I want to figure out what the y velocity is, the vertical velocity. Okay, and again for that one, I can use the sine of 37 because this over this equals the sine of 37 degrees. Okay, so to solve for that, I've got 50 meters per second times the sine of 37 degrees, which is 0.6. Okay, and that's going to equal 30 meters per second. Okay, so now I'm going to go ahead and write them right here. This guy equals 30 meters per second. This guy equals 40 meters per second. Now I've got some good information for solving a parabolic motion problem. Okay, so let's look at an example. I've got my object, my cannonball. I'm firing 50 meters per second at a 37-degree angle above the horizon. How long before it reaches its maximum height? Okay, well, in that case, I'm looking at those velocities that are causing it to go up, which is my y velocity, 30 meters per second, and a velocity which is going to cause it to go back down. And I know it's going to stop moving up when that velocity, 30 meters per second, equals the velocity due to gravity. Okay, at that point, it'll stop moving up and it'll start moving back down. So I know that my y velocity is 30 meters per second. Okay, and I know the force of gravity, in this case I'm going to simplify, I'm just going to say is 10 meters per second squared, don't forget to square it, times t. Okay, now, and t is in unit in seconds. Okay, and when I multiply that out, my seconds here are going to cancel with one of those, so I just have meters per second. Okay, and I have 30 meters per second equals 10 meters per second times t, and that's a pretty easy problem. T equals 3. Okay, good. So that means it's going to spend 3 seconds going up before it starts coming down. Okay, now how high does the object rise? Okay, so again, to calculate the distance it's moving up, I have two velocities that I want to calculate, right? The first one is the velocity going up, vertical velocity, 30 meters per second, and the second one is t. Okay, I'm sorry, times t, and then the second velocity is 1/2 of gravity, the force of gravity, which is going to be pulling it down. So to solve that, I say 30 meters per second, and my time is 3 seconds, times 3 seconds. Okay, and I'm going to subtract the velocity due to gravity, because that's pulling it in the opposite direction, right, which is 1/2 10 meters per second squared, and times t squared. So this is going to be 3 seconds squared, which is going to equal 9 seconds squared. Okay, my seconds squared cancels with that. Okay, and 10 times 9 is 90, and 1/2 of that is 45. Okay, and my velocity going up is 3 times 3, cancel my seconds, so I get 45 meters is the pulling it down, and 90, 3 times 3 is 90, going up, so my answer is 45 meters. So my cannonball rises 45 meters in the air, okay? All right, well now I know a lot of information, and now let's look at a couple more problems that you're probably going to get asked, okay? Another question might be, well, how long is that cannonball going to spend in the air before it lands, okay? Well, to figure that out, I've got the information. If it's going to spend 3 seconds going up, okay, 3 seconds going up, it's going to spend the exact same amount of time coming down, okay? So my answer there is 6 seconds, okay? All right, now another question that's commonly asked is, how far is that going to land from where I shot it, right? I want to know where my cannonball is going to land, maybe hopefully on my target, okay? So that distance can be calculated by the velocity on the horizontal, okay, which is right there, okay, times time. So if I calculate that, I've got 40 meters per second times 6 seconds, my seconds cancel, and I get 240 meters. So my cannonball is fired 240 meters away, okay? And that's how you solve a problem and many steps of a problem using parabolic motion.